This will be for the con exercise, graphs of logarithmic functions. The graph of y equals log base 3 of x is shown below. Which of the following is the graph of 4 times log base 3 of x plus 1? So there's really two ways to do this. I am going to do a combination of both. Okay, the original equation was y equals log base 3 of x. So if you recall, when you add or subtract from just x and not the entire equation, it shifts the function to the left or right, okay? And it's actually reversed in the sense that plus 1 will shift it to the left and not to the right. Okay, so the plus 1 makes it shift left 1 unit. All right, and when you multiply the entire function by a number that's greater than 1, that is making the graph have a vertical stretch. Okay, that just means that it increases or decreases faster than the original. All right, so let's apply these two steps to the graph and see what it looks like. Now, we said it's going to shift left 1 unit. Okay, so I can take this point right here and put it here. And also, I can take this point right here and put it here. Okay, but we also said that the whole function is going to be multiplied by 4. All right, so all of the y values are going to be times 4. So right here, this point is at y equals 0. That's going to stay. Right here, instead of this point, this is -4, so this must be y equals -2. -2 times 4 is -8. So this point will really be down here. All right. And let's just take one more point. This point right here is at y equals 2. We're going to shift it left 1 and then multiply it by 4. So instead of being y equals 2, it's going to be at y equals 8. All right, so connecting the new points, it's going to be like starting with this point and this point and this point right here. So it's going to be something. It's going to be something like that. All right, so it's going to go through the origin at -1, x equals -1, it's y equals -8. And at x equals 8 or 9, it's going to be at y equals 8. So let's take a look at our graphs. Just to recall the points, this one here is, I'll write it out. Just this coordinate here is 9, 8. And it passes through the origin. This point here is -1, -8. All right, and this is the origin. So we're going to look for those points. All right, we said 9, 8. So not quite. Passes through the origin here. This is -1, -8. All right, A is close. Definitely not B. This part should be over here. At answer C, -1, -8, and 9, 8. No, it's not C, and it's definitely not D. I'm thinking answer A. I think I messed up one coordinate. Maybe I should have said 8, 8. Let me see. Yeah, close enough. Okay, I said 9, 8. This point is at 8, 8, passes through the origin, and this is -1, -8. So it's answer A. All right, another way to do this is to plot some x, y coordinates. just as an example, if we did 4 times log base 3 of the number 1, that's the same as 4 times log base 3 of 3 to the 0. Okay, we know 3 to the 0 is the same as 1. And log base 3 of 3 to the 0 is just 0. And 4 times 0 would give us 0. All right, so what value of x would make this equal to 1? Well, if x were 0, that would make this 1, and then the whole thing would equal 0. So 0, 0 is one of the points. And I also know that if we did 4 times log base 3 of 3 to the first power, log base 3 of 3 to the first would just be 1 times 4, and that's 4. Okay, so 3 to the first is the same as 3. What value of x would make this 3? Well, that would just be x equals 2. So at x equals 2, y equals 4. All right, and I can also go the other way as well. If I did 4 times log base 3, actually, I won't go the other way because I was going to say 3 to the negative 1. Okay, but that is the equivalent of 1/3, and I'd have to make this a fraction. Let's do 3 squared for the final value. Okay, 3 squared. Log base 3 of 3 squared is 2 times 4 is 8. Okay, so but 3 squared is 9. What would make this value equal to 9? Well, that would be x equals 8. So at x equals 8, the function equals 8. So I can use these points and look at the choices, 0, 0, 2, 4, and 8, 8. So if you look at the choices again, here's 0, 0, here's 2, 4, and here's 8, 8. So A matches all of them. Okay, you can see the other choices don't match. All right, so again, I come up with answer A. So you can do the apply the shift functions, apply the translations, or you can just plot points. All right, use the interactive graph below to sketch this graph right here. So we need 2 points, and we need to see what direction the graph heads in. This is basically an asymptote. All right, so let's take a look. All right, I'm going to get a couple of points the easy way. We only need 2 points. All right, so let's see. 5 times log base 3. All right, again, we're using log base 3 for some reason. If we did 3 to the 0 minus 5, okay, log base 3 of 3 to the 0 is just 0. Times 5 is 0, and minus 5, that's going to be negative 5. All right, so the y value is negative 5. What value of x would make this 3 to the 0? Well, 3 to the 0 is just 1, but this is negative x. So if we took the negative of negative 1, that would make this equal to 1, which is the same as 3 to the 0. So at x equals negative 1, y equals negative 5. All right, and we'll do one more easy point. Okay, we'll do 5 times log base 3 of 3 to the first power and minus 5. Okay, so let's see. Log base 3 of 3 to the first power is just 1. 1 times 5 is 5, minus 5 is 0. Okay, so the y value is 0, and 3 to the first is the same as 3. What would make negative x equal to 3? Well, that would have to be x equals negative 3. All right, so at negative 3, y is 0. All right, so we have 2 points, and let's see if we can find the asymptote. Okay, I don't think it will be too difficult. Now, as this x gets more and more negative, this whole thing gets more and more positive. Okay, so you can keep going. You can keep going in the negative direction. Okay, and y is going to get more and more positive. But you cannot take the log of 0. All right, if you want to try it on your calculator, you'll see you'll get an error message. So we know that we cannot do log base 3 of 0. All right, so x cannot equal 0. And we said you can go more and more negative, but if you went into positive numbers, this would be a negative, right? If x were positive, this would be a negative, and you can't take the log of a negative either. So x cannot be 0, and it can't be positive either, because it would be the log of a negative. I think the simplest way to do this, since we're taking the log of negative x, we can just say negative x must be greater than or equal to 0. Okay, and then if you multiply both sides by -1, remember when you multiply both sides by a negative, the inequality symbol has to reverse. Okay, so -1 times negative x is x, 0 times -1 is 0. X must be less than or equal to 0. Okay, so that's going to be this green line here. All right, x has to be less than or equal to 0. So the green line, I'm going to move that to x equals 0. Okay, at x is -1, y is -5. So let me go to -1 on the x and -5 on the y. Okay, and the other point, x is -3, y equals 0. So I'm going to go to x equals -3 and y equals 0. So I got these 2 points, -1, -5, and -3, 0. And x has to be less than or equal to 0, so I put the asymptote at x equals 0. Okay, you see the graph, it will never go past x equals 0, okay, even if you kept going down. So that's it right there.